everyone, just a few notes before we get to the main content of this video.
We decided to keep our boat, Emerson, and added a small travel trailer to our collection this spring. For those new to our channel, we avoid the camera and obscure our voices with the help of AI.
Our primary target audience is still friends and family, and, as before, we are not trying to build a channel.
Consequently, you won't hear us asking you to like, subscribe, and comment. But we do appreciate feedback and ideas that aren't ours.
We'll address in future videos why and how we selected this particular RV. For now, please join us as we are setting up Snuggle Bean, our 2025 nüCamp tab, 400 Boondock Edition Black Canyon.
We'll start with an overview of the Lithium upgrade, followed by 3 items that are not only important but also high priority in our book: security pins, a shore power setting, and the use of the port for portable solar panels.
Our Victron Smart Shunt, inverter charger, and solar controller were not configured correctly, so we'll step through the configuration process for those components.
We then share some thoughts about optimizing our 12-volt system as it relates to using dip switches, the assist mode, and using DC to DC chargers. No worries if you don't know what these are. We'll explain.
Please pause the video for a moment to read our disclaimer. It can also be found in the video's description. These are most of the components of the lithium battery upgrade. Missing is the load center, which is located below the galley drawers. All of these components are high quality and from leading suppliers. Let's take a moment to review what we have here.
There are 4 battle-born heated lithium-ion batteries, wired in parallel with high-quality wires and connectors.
The smaller wires are used to turn on the battery's heater function, so we can charge the batteries when temperatures drop below freezing, and discharge them when temperatures drop below -4 degrees Fahrenheit or -20 degrees Celsius.
Fuses or circuit breakers should always be located close to the power source. And nüCamp installed an appropriate fuse near the batteries as it should be.
The big blue box is a Victron Multiplus. It is a combination of a charger that can utilize 50 amps of 120-volt shore power to charge our 12-volt batteries at a rate of 120 amps and a 3,000-watt inverter that literally can run everything in the Tab 400. That can be good or bad, as we'll discuss later in the video.
The device against the rear bulkhead is called a VE-Bus Smart Dongle. For our purposes, this dongle allows us to remotely control the inverter charger via Bluetooth.
The last component in this view, mounted to the curbside bulkhead, is the Smart Shunt. All current from and to the battery runs through this device, so it can measure it. As we will discuss later, that alone is not enough to give you an accurate status of your batteries.
Power enters the system in 3 ways. This is the inside of the 30-amp shore power connection, and behind this wiring is the backside of the connector for a portable solar panel.
You can see this connector from the outside by looking inside the driver's side Nautilus wet compartment.
Wires are first routed into the compartment containing the all-day system, more plumbing, and also the Victron solar charge controller for the roof-mounted solar panels.
From there, wires are routed underneath the underbed drawer, and in the case of the output from the solar charge controller, the wires are routed to the battery disconnect switch located in the passenger side storage compartment.
If for some reason you are not getting any charge from your roof-mounted solar panels, you may want to check this fuse.
And if you are not getting power to any of the 12-volt circuits in your fuse box or load center, check this rather large circuit breaker. It disconnects all fuse 12-volt consumers.
For our other sources of power, wires continue into the main compartment, where the wires for the external solar panel connect directly to the batteries, and the shore power connects directly to the Victron charger.
Both of these facts become important considerations, and we will refer back to them later in this video. In order to manage, configure, or just view the data from our Victron devices, Without buying additional equipment, we need to use the Victron Connect app.
We installed the app before picking up Snuggle Bean, and the initial results were rather boring.
Once we arrived at the dealer, the app showed all devices within Bluetooth range.
And that is problem number one. If we can see the devices of others, they can see ours.
In order to connect, we had to enter the default code of 6 zeros. Anyone with that code, which is a very large group, could potentially access our devices. Once the trailer was ours, we changed this code to keep others out. We don't want unauthorized third parties to change settings and possibly lock us out of our own devices.
Here's how to do it. Select one of your Victron devices. Select the settings or gear icon. Select the hamburger menu in the upper right corner and then Product Info. Then scroll down to PIN code and change the code.
There are also other ways to change the PIN, but this way works every time.
Since you are already in the Victron app, let's spend a few more seconds to protect your RV or boat.
Our inverter charger came configured for 50 amp service. It should not be. We'll explain. Let's start on the outside of Snuggle Bean.
Snuggle Bean's shore power connection can be found on the driver's side, just aft of the axle. nüCamp placed a label here that should not be ignored.
In our RV and boat travels, we encountered 4 or 5 situations that required us to plug into 50 amp service, or not at all. Here is what happened with our motorhome in Olympia, Washington.
I had assumed incorrectly that the 30 amp circuit breaker on our motorhome's power distribution panel limited the incoming power to 30 amps. It does not.
A higher current will find the weakest link and cause damage, or worse. We changed our current limit for Snuggle Bean to 28 amps. This setting ensures reliable operation, protects the electrical system, and complies with safe power management practices.
Since shore power is wired directly into our Multiplus, we are confident that there are no additional circuits that could overload our 30 amp connection. As our third point in this security and safety chapter, a few words about the external solar port.
As we showed you earlier, the external solar port in the wet bay of our nüCamp Tab 400 is wired directly to the batteries, which in turn are serving your 12-volt circuits and appliances.
That was okay in a time when portable solar panels included a small solar charge controller. And if that is what you use, all is well.
Today, none of the panels we would recommend come with a controller. Do not plug a portable solar panel into the pre-wired port unless you are 100% certain it provides 12 to 14 volts. Our rooftop solar panels, for example, operate at nearly 40 volts.
High voltage would likely cause the batteries to shut down, and results for your 12-volt consumers would be unpredictable.
We recommend to get whatever portable solar panel works best for you, and then install an appropriate solar charge controller between the port and the batteries.
Let's configure the Victron components of our 2025 nüCamp Tab 400.
Before we do, and to give credit where credit is due, we would like to refer you to an excellent resource. Until recently, Explorus Life had a contract with Battleborn batteries, and all of their installations were done with those batteries and Victron components. That makes it very easy to directly use the information provided in their videos.
Our information for the Multiplus and the solar charge controller is from Explorus Life. For the shunt configuration, we had to contact Battleborn's parent company, Dragonfly Energy. So let's start here. Select the settings or gear icon. Then select battery.
This is how our shunt was configured. Yours may be different.
Touch charged voltage and change the value to 14.2 volts. Touch tail current and change the value to 4%. The Pukert exponent for Battleborn lithium-ion batteries is always 1.05. the charge efficiency factor is always 99%. The battery state of charge on reset should be clear.
Snuggle Bean's Smart Shunt will now be able to correctly calculate the battery's state of charge and time remaining based on its measurements. Now let's use the iPhone Victron Connect app to configure the solar charge controller.
Select the settings or gear icon. Then select Battery.
This is how our solar charge controller was configured.
Turn Expert Mode on to gain access to all of the settings. Set the absorption voltage to 14.6 volts. Set the float voltage to 13.5 volts. Leave the equalization voltage as is. Change the absorption duration to adaptive. And confirm that the absorption time is 30 minutes per battery. For Snuggle Bean, 2 hours is correct. As before, change the tail current to 2 amps. If your app needs to reconnect as ours does here, just return to where you left off. Leave equalization as is. It is not needed for these batteries. Temperature compensation is not needed and can be left disabled. The batteries have built-in low temperature cutoff, and thus we don't have to configure it here.
That's it for the solar charge controller. The Victron Multiplus has been around for over 20 years. That makes it very mature and also rather old school. The latter means that it does not have Bluetooth built in, and it needs to be programmed or configured with the help of a dongle that translates its native VE bus protocol to USB. For us, this means that we need to use a laptop to configure Snuggle Bean's inverter charger.
We unplugged the Ethernet cable from the Bluetooth dongle and routed it to the MK3 USB-C dongle, which in turn was plugged into our laptop. Select your Multiplus. Select the settings icon. Select Enable Settings. The password is ZZZ. Select General. If you are in North America, leave the system frequency at 60 Hz.
We'll use the current limit to show you an issue with this particular version of the app. When you enter a new value, simply clicking OK will not retain the value. A quick plus minus or minus plus will make sure the value is retained when you click OK.
Turn Dynamic Current Limit on. Select Inverter. Make sure the inverter output voltage is set to 120 volts. change the DC input low shutdown voltage to 11.5 volts. Then change DC input low restart to 13 volts. Change the DC input low pre-alarm to 12 volts.
If you already know that you want the power assist feature on or off, you can change the setting here. We will leave ours on for now, and we'll share our thoughts along with an example later in this video. The changes we made require a reset of the device. Fortunately, that reset is very quick.
Now select Charger. Change the absorption voltage to 14.6 volts. Next, change the float voltage to 13.6 volts. The maximum absorption time for us is 2 hours. Change the charge curve to fixed. Turn lithium batteries on.
And that is it for the Multiplus. All of our factory Victron gear is now fully configured. We decided to buy the factory Lithium upgrade instead of building a system ourselves. We thought that doing so would give us a fully configured and optimized system that would perform as well as possible under its warranty.
When we first saw our Tab 400, her 50-amp Multiplus had tripped a 15-amp circuit breaker, and her batteries were rapidly depleting. Once service was restored, the batteries charged at 13.6 volts, which we were told was pretty close.
In its service manual, Victron describes the use of 8 dip switches to program the Multiplus. We were advised that Victron maintains that the Multiplus can be configured with these switches alone. They stated, "Why would we have the dip switches if they couldn't be used to configure the device?"
Let's explore. The Victron Energy Multiplus was introduced when our daughter was not old enough to go to school. Today, she is teaching school. When the Multiplus was introduced, Battleborn, Renogy, and other leading lithium-ion battery suppliers did not yet exist.
Here are the settings that can be affected with the DIP or dip switches. None of the available settings are suitable for lithium-ion batteries.
Perhaps a Victron professional can get the configuration pretty close.
Battleborn publishes a battery life of 3,000 to 5,000 cycles. Does pretty close result in 3,000 cycles and exact results in 5,000?
We don't know. What we do know is this. We just used the settings recommended by Battleborn to change the configuration of a Multiplus that had already been configured by a technician using the unit's dip switches.
You will need to decide if pretty close is good enough, or if you would rather optimize your lithium upgrade.
When the power consumed by Snuggle Bean's appliances and outlets exceeds the power coming into the system, the Power Assist feature can use battery power to supplement the overall power needs.
We like this feature quite a bit, but using it can have unintended consequences, so we wanted to share a couple of things about it.
For Power Assist to work, the inverter has to be turned on, and the AC input current limit has to match the incoming shore power.
This example assumes 15 amp shore power, and the Multiplus current limit is set to 15 amps.
If the input current limit is not set correctly, the Multiplus may attempt to draw more current than the shore power connection can supply. An upstream circuit breaker would break the shore power circuit, and the inverter would take over.
This is no longer a temporary power assist scenario. Instead of the batteries taking a small hit, the system would draw down the batteries.
If the inverter is not set to be on, power assist will not work. An appliance that would otherwise trigger the power assist mode would simply fail to work properly, or all of the 120-volt appliances could falter once the current limit is reached.
All of this to say, we like power assist. We will just make sure that all of our settings are correct, so power assist is what we actually get.
To use or not to use a DC to DC charger. We think we should have one, and so should you, but not everyone agrees.
We wanted a DC to DC charger for 2 reasons. 1. We want to isolate the car and trailer batteries. Our tow vehicle's alternator varies voltages wildly with complete disregard for the charge wire in the 7-pin harness or trailer batteries. 2. We wanted to get whatever charge we could through the 7-pin harness without modifying our tow vehicle.
The charge and ground wires are 10 gauge from the car's fuse box near the driver's side rear fender to the 7-pin connector, continuing in the tab's harness all the way to the 12-volt distribution panel. With these settings, the DC to DC charger will use the correct charging profile or nothing at all, just like we wanted.
And now you know what we know. Let's go camping. Thank you for joining us.
Thank you.